calculators. Let's start with variables. Just like in algebra, variables are single letters that store numbers. You can think of variables as a container with a value inside. On your calculator, for example, the x key prints the x variable. You saw x in part 2 of these videos where I showed you how to graph. In order to put a number into a variable, you use the stow or store key at the lower left of your calculator. For example, if I wanted to put the value 3 into x, I would press 3, stow, and then x. Your calculator prints 3, right arrow x, indicating that it's going to store the number 3 into x. Anytime I want the number 3, I can now use x. For example, if I just type x and press enter, I get 3, because that's the value of x. I could type 2x, which is 2 times x, and I should get 6. I could do something complicated, like x squared plus 3x plus 1. 3 squared is 9. 3 times 3 is also 9, so 9 plus 9 is 18, plus 1 is 19, so the answer should be 19. Your calculator has 27 variables, a through z and theta. You can see each of these variables in green text above the keys on your calculator. As you learned in part 1 of these videos, to access that green text, you press alpha and then the button with green over it. So if I want the a variable, I press math because math has a small green a over it. If I wanted something like p, I could press alpha and then 8, which has p over it. Let's say I wanted to find the volume of a box. Let's say this box has a width of 3, a height of 4, and a length of 5. Because the width is 3, I will store 3 into the variable w for width. Next, I'll store 4 into the height, h. And finally, I'll store 5 into the length, l. Notice that after each store statement, I have pressed enter, which instructs the calculator to complete that store. Now I have 3 in w, 4 in h, and 5 in l. To calculate the volume of this box, I know that it's the width times the height times the length. So I can press w times alpha h times alpha l. When I press enter, the calculator will multiply w times h times l to give you the volume of the box, which is 60, or 3 times 4 times 5. Your calculator, as I showed you previously, can also do implicit multiplication, so I can type w h l to also get 60, the volume of the box. The next thing we should look at are lists. If variables are single containers that store a number, then you can consider lists as a series of buckets, each of which holds one number. For example, your calculator can have lists named L1, L2, L3, L4, L5, and L6. You might have encountered these in trying to deal with stats plots before, but if you haven't, they are things that you can type by pressing second and then the key corresponding to L1 through L6. If I try to use L1, you can see that it currently has 6 items in it. However, on your calculator, you might not have anything in your lists yet. So the first thing we need to do is define how big our lists are. We'll use L1 for all these examples, and say we want to make our list 3 elements long. To do this, we type 3 store, but then we can't do store to L1 because L1 holds a series of numbers, not just one number. In order to set the length of a list, you use the dim or dimension command. To get to the dim command, press second, then stat for the list menu, move the cursor over to the ops menu, and press the down arrow twice to get to dim, and press enter. Again, that's 3 store, second stat, move over to ops, and choose dim. Now you specify the list that you want to set the dimension of. I said we'll use L1, so this is 3 store dim L1. The calculator prints out 3, confirming that it set the length of L1 to 3. Now, if I try to print L1 again by pressing second 1 and enter, you see that L1 is now 3 elements long. Now you'll want to put some contents into L1. Just for fun, I'll use L1 to store the dimensions of that box I just mentioned, with dimensions 3, 4, and 5. There's two ways that I can do this. One way is to store to each element of L1 individually. First, I'll store 3, 2, and then L1, parentheses, 1. What does this mean? This tells the calculator, store 3 into the first element of L1. When I press enter, the calculator confirms that it has stored 3 to the first element of L1. I'll then store 4 into L1, parentheses 2, the second element of L1. And finally, I'll store 5 into the third element of L1. Now, if we did this correctly, L1 will contain 3, 4, and 5. So if I simply press second and then 1 again, I get L1, and I press enter, the calculator prints out 3, 4, and 5, just as we expect. The other way that you can set a list is to explicitly enter all of the items in the list. And you can see that your calculator displayed the list contents with these curly braces. To enter a list for the calculator to store, you'll also use these curly braces. Let's say that I made my box a little bigger. Maybe I combined 8 boxes together, so I have a 6 by 8 by 10 box now. If I press second, parentheses, which has a little curly brace above it, I'll get an opening curly brace, and I press 6, comma, 8, comma, 10, and then I can optionally close those curly braces. This is a list 3 elements long, containing list 1 is 6, list element 2 is 8, and list element 3 is 10. Now I can store this directly to L1 without having to specify an element number afterwards. When I press enter, you can see the calculator confirms that L1 now contains 6, 8, and 10. Let's find the volume of L1. We can do L1, 1, which is the value of the first element of L1, times the second element of L1, I made a mistake there, that should be L1, times the third element of L1. The answer should be 6 times 8 times 10, or 480. Another thing we can do is use one of the several commands available in the list menu, second stat, to perform math on a list. You can find the minimum value, the maximum value, the mean value, which is the average of all the items in the list, the median, the sum, the product of every element in the list, and even the standard deviation and the variance of all the items in the list. We want to find the volume of a box with dimensions stored in the list, so we'll use the product, or prod, of L1. This will multiply every element in L1 and return that product. Again, it's 480, just as we'd expect. Finally, let's talk about matrices. If a list is a series of buckets that can contain values, say a one-dimensional set of numbers, then a matrix is a two-dimensional set of numbers. What exactly does that mean? Let's look at the matrix menu for a bit of a clarification. If we press second and then x to the negative 1, which has matrix written above it, we'll get to the matrix menu. It says names, math, and edit. Let's try editing a matrix. I see that the one selected there is A. Little square braces mean matrix, so I'll press enter. First, it's asking me how big I want the matrix to be. Now, I said that a matrix is two-dimensional, which means that it has a height, a number of rows, and a width, or the number of columns. Let me set matrix A to have 3 rows and then 2 columns. And I'll press enter there to make that take effect. You can see that this has 3 rows and 2 columns now. And in the matrix editor, I can edit the values of each of these elements. Let's say I set the second row, first column, to 1. I'll set the first row, second column, to 2. And I'll set the third row, second column, to 3. Now the items in my matrix are 0, 1, and 0 in the first column, and 2, 0, and 3 in the second column. How can I use this on the home screen? Well, if I press second and then x to the negative 1 for matrix once again, I'll get the matrix menu again. Names, A is 3 by 2 as we just defined, so I can press enter to paste just the name of the matrix A to the home screen. The calculator will print out the numbers that I just put into that matrix, 0, 1, and 0 in the first column, 2, 0, and 3 in the second column. Just like lists, you can access single elements of the matrix. So for example, I can access row 2, column 1. How did I do that? Well, again, I went to second matrix, I selected the name of matrix A, and then in parentheses, I put first the row and then the column of the element that I want in parentheses. If I press enter, I get the value of the matrix at that particular spot. Unfortunately, unlike lists, you can't define matrices with your own names. If you look through the Names tab on the Matrix menu, you'll see that there are only 10 matrices, A through J, and those are the only matrices that are available. Also, new on the TI-84 Plus CE, you can only have up to 400 elements in a matrix, so you could have a 40 by 10 matrix, but you couldn't have a 40 by 11 matrix. Let me show you two more things you can do with matrices on your calculator. The first one is to easily enter matrices on the home screen. To do this, press Alpha and then F3 or Zoom. This will bring up a little context menu on the home screen that lets you enter a matrix of any given size from 1 by 1 up to 6 by 6. To use the example I've been using so far, I'll select 3 rows and I'll keep 2 columns and press Enter on OK. This will bring up a little template that has 6 spaces for me to type in values, and if I use the same matrix as before, I can put 1, 2, and 3 inside my matrix. When I press enter, the calculator will just echo back this matrix because I haven't really asked it to do any math with it. Finally, just like with lists, you can do math on matrices. To find these operations, press second and x to the -1 to once again go into the matrix menu, arrow over to the Math tab, and you can see different operations for working with matrices. For example, at the top is determinant, the next one is transpose, and there are many other options for manipulating matrices. You can find details of what all of these different commands do inside using the TI-84 Plus, available on Amazon and bookstores and other good places where you might find books. Let's try finding the determinant of a matrix. So I'll press determinant, and let's try using what we just learned in order to enter a matrix on the home screen. So I'll press Alpha, Zoom again to get the F3 menu or matrix. This time, let me choose a 2 by 2 matrix and then move my pointer down to OK and press enter. Now I'm finding the determinant of a 2 by 2 matrix. To make it simple, let me put 2 here and 2 here. So this is actually what's called a diagonal matrix. When I press enter, you'll find that the determinant is 4, which is correct. In physics, you'll often learn that the determinant of a 2 by 2 matrix is the sum of the top left and lower right items minus the product of the upper right and lower left items. You can also do things like get an identity matrix. So to show you one more command, I'll go to identity in the matrix menu and choose 3. This will give you a 3 by 3 identity matrix, which it's a diagonal matrix of 1s on the diagonal and 0s everywhere else.